We're going to have a look at sketching any trigonometric function. Now, I call this one the sledgehammer technique. It's going to work for any trig function, but you don't need to use it for every trig function, just the ones with the multiple transformations. Firstly, when we're sketching a tough, challenging trigonometric function with multiple transformations, we need to consider many elements of the sketch. Start off by ensuring that your trigonometric function is in the correct form. Look at the learning goal. That's got the correct form. All of the transformations of A, B, C, and D assume that we've got the function in the correct form. So get the form right before you do anything else. Secondly, we're going to identify the variables A and B and provide details on how these influence the sketch. Remember, A is the amplitude and the reflection, and B tells us the period. Once you've done this, you'll draw up a Cartesian plane and scale the x-axis according to the period. Now, when we are considering the scaling of our x-axis, we're going to need to consider the period and, in the case of multiple transformations, the phase shift. Complete an initial sketch of the function by considering the transformations of A and B. Once completed this sketch, identify the maximum and the minimum points of the trigonometric function. After this, you consider the transformations of C and D. These parameters will shift the graph up, down, left, and right. We consider the transformations of the up, down, left, right shifting with the maximum and minimum points. We replot these points on the same Cartesian plane to have a second and final sketch with all of the parameters included. Quite a process. It's a sledgehammer, so use it with a bit of caution. So here's an example when I think a sledgehammer is necessary. I look at this function y equals -2 cos outside of 3x minus pi on 3 plus 2. 4, and we want to sketch it between 0 and 2 pi. This function is particularly disgusting, really. It's filthy, right? We need to clean it up. So first things first, we need to put it in the form. Okay, so once you clean up the form, and that is just forcing it to look like the general form. So we need to factor out a 3, and you factor it out appropriately. So pi on 3, if you're factoring out a 3, you multiply the denominator, so you got pi on 9. The second thing we want to do is we want to consider the A and B transformations. So when our A is equal to -2, this is going to tell us the amplitude and whether or not this graph is reflected. So it is a cos graph, the amplitude is 2, and it is reflected. So that's what that implies. B is equal to 3, therefore the period, now remember the period occurs 2 pi radians, but if you were speeding up that process, it happens 3 times as quickly. So the period is going to be 2 pi divided by 3. Now, we just need to be a little bit careful with our incremental points in our initial sketch. So incremental points, we know that the period is 2 pi on 3. I'll just make a note. That's 120 degrees. 2 pi on 3, 120 degrees. We divide that by 4 because we need to split up to get those 4 incremental points between for that full period to occur. When we do that, we get 2 pi on 12, we simplify that down to pi on 6. So these are our incremental points. However, what you'll notice with the phase shift, and I'll highlight this here, the phase shift is pi on 9. So we will be needing to shift our graph across pi on 9 units. So that means we want to scale our axis appropriately so that we can do that nicely. Now, in order to do that, we need to find the lowest common denominator between pi on 6 and pi on 9. Okay, and we can do that. We can say, well, pi on 6 is just 3 pi on 18, and pi on 9 would be 2 pi on 18. So the lowest common denominator is 18. Just to reiterate, this is our phase shift, or our shifting the left and right. And this guy here, these are our incremental points. So I'm going to go to sketch it. So we're going to do an initial sketch of y equals -2 cos of 3 of x with the scaling done so. So we are scaling by, it should have been by pi on 6. However, we're scaling it with 3 pi on 18 because I want the phase shift and the scaling to have the same denominator so I can see it easily on the graph. So I'm going to go ahead and just quickly plug those in. Okay, so now that I've got my axis scaled, I know that this is a -2 cos of 3x. Now cos of x typically starts up here at the point 2, but it's reflected because of -2, so it's going to start down here and it follows this circular pattern. Now just to point out here, okay, 36 pi on 18 is 2 pi. So that fits between our domain of 0 and 2 pi, just to make that very clear. We want to identify max and min points and say what this graph is. This graph is y equals -2 cos of 3x. And we need to identify these maximum and minimum points because that's how we're going to shift it. That's how we're going to shift this graph. Okay, so now that we've identified these maximum and minimum points, we've done an initial sketch, we're going to consider the transformations of C and D. So again, I did say this is a sledgehammer. You're not going to need to do this process for every single question, just the ones that are really hard. Okay, so this is how the transformations of C and D work. You're going to identify what is C, what is D. Make sure you've already identified the maximum and minimum points of the initial sketch. And so as this shifting occurs, you take the X coordinate and you shift it along by +C, and that'll give you the left or right shift. And then you take the Y coordinate of the same point and you shift it up or down by D units. So an example of this, if we just plucked out, we're going to pluck out the point 6 pi on 18 and 2. So this point is going to become 6 pi on 18 plus pi 2 pi on 18. Because that's why we did this business before. This thing here was our pi on 9, that was our phase shift. So this thing should also be 2 pi on 18. So I've done that phase shift accordingly, and then we get the y point 2 plus 2 for D. We say that's going to be 8 pi on 18, comma 4. So that's where that point is going to go. That's just an example of one of the points shifting. So our last step here is to do sketch number 2. So it's a double sketcher. Okay, so we saw this point here, this guy here, it moved up 2 units and then along 2 units. Okay, so just so we can see the transformation here, we've gone along 2 pi units, so that would give us 8 pi on 18 and 4. That's going to be 8 pi on 18 and 4. And we do that for all their max points and our min points. So this guy here is going to go along 2, up 2. This guy here is going to go up 2, along 2. This guy here is going to go along 2 and up 2. Alright, this guy here, up 2, along 2. And well, that kind of cuts off there. And now what we'll actually notice here with this guy as well is that it goes into and up to kind of get to this point here. Now before we do this initial sketch, to help make it look like a trigonometric function, I typically like to write my equilibrium equation in. That is the value of d. So I know d is equal to 2, so you get y equals 2. This is not a necessary step, but I like to do it so I can make sure that my trig function looks like a trig function. This graph is, it's y equals negative 2 cos of 3 outside of x minus pi on 9 plus 2. And we label what all of our points are. Okay, so just reflecting back, in order how the x and y, the x-axis was scaled, we saw it's kind of important to use that lowest common denominator there, so we can see the scaling nice on our axis and get it to look relatively clean.